Okay, so this is lecture 3. This is the second week. We are going to discuss about different types of green infrastructure so that you know which projects or what you should focus on your project. So it will give you some overview. And then also we'll start using mass balance equations to solve some of the problems related to green infrastructures. And these are the mass balance equations that you have already learned in CEE159. So I also share the links where you can learn them again. It's basically one lecture in CEE159. So you should watch it if you didn't take that class. But if you didn't, that's fine. You can learn in this class. But I'll not go as details as I did in CE159. It's a simple concept, but it's going to be used multiple times. So you got to have a lot of exercise or example problems that you need to solve. So these are the link for the class. If just in case this is keep it handy for CampusWare. I have seen that around 60 students join CampusWare so far. So that means we are missing 20 students. I just want you to know that most of the communications I do through CampusWare. So if you are not on CampusWare, let me know if there is any difficulty, because you will miss out some of the announcement. Because I don't want to send emails, because that's CampusWare makes it easier to keep everything on a record in one place. Once it goes to email box, it's just hard to, you get so many emails, so it's very hard to keep track of what is out there. Also, your questions are always helpful for somebody else, because you might have similar question like others. So if when you ask, it does help the entire class. So ask question through CampusWare, and TAs and me or any other students who already know the answer, they could also help. Again, all the lectures will be on the YouTube list, so you can play that one. These are a couple of announcements or reminders. Office hour every week on Wednesday, 1 to 2 p.m. I am typically present first half hour. If nobody shows up, I leave at 1:30. But if you tell me that you are coming at 1:30, I'll wait. But again, I just keep that time off so that in case you have any questions. But you don't have to attend if you don't have any questions. But I do, if you have about projects, this is a good opportunity for you to show up. Quiz 2, as I said, every week, every second week, there is a quiz. The quiz are very much similar to everything on the slide will be part of the quiz. And a good indication is the homework questions. So those are the questions you should learn. Homework questions are very easy. First homework is you just go to the link, find the information, write those, whatever you think based on that. So it should not take more than, most of the question is pretty like 5-10 minutes. So you should try to finish it quick. But again, this quiz is going to be released on Thursday at 8 p.m. and said it will be active until midnight Friday. So that means you can take any time before midnight Friday. But once you open the quiz, you'll have 20 minutes. If it is 10 questions, it will be 20 minutes. So just know that this is something, and it's open book. You can open all your slides, anything you want. If you can take at your own time. But once you open, you have to finish it. You can't just come back again. Homework 1 was out. It's due on Friday. Again, this is not a very hard homework. It's very simple questions. This will just give you the reason behind this homework question is so that make you read some of the materials that otherwise not every times people read. But it should be fast. Okay, so and you can see on the grade scope, this will say when it's due. Anytime there is extension, I change it here so you can see that update. But this homework is simple. It will not have extension unless really you have some specific reason for any health issue or any other things, let me know. All right, for projects, I encourage you to create a Google Doc for your project so that all of your team members can work simultaneously. And you can share that link with me through CampusWare so that the link is there. And we can always, anytime we discuss, we meet about your projects, it's there. So things has been up. The idea here is that you keep updating the project so that you keep writing, because by the end of this quarter you'll be finished writing. You're writing always something every week. And you should meet with a TA either during his office hour or discussion session as a group, so that he can guide you for your projects. We'll give you a lot of instructions, but you got to first start. So this was one of the questions was asked, that you have this different grade. Forming a group research about type of grid infrastructure. If you see research about type of grid infrastructure, there is no way for us to know whether it did or not. We just assume that you did. Um, Forming a group, at least you made that effort, so you get 5%. Okay. So if you don't have a group members, send me an email. So I'll put you in one of those group. And if you already have a group, let me know ahead, so that uh, I know that you are part of a group. Also, I know how many students are in your group. For instance, if one group send me emails, they have 6 students, I know that they can accommodate another 2 students. So that way I know if one student didn't have any groups, then I'll just put them in that group. So keep send me email or put on the campus where. Um, so again, as you see, brainstorm, research, idea, all those things has to happen with Renan. So we'll help you. You have to speak the time with the TA discussion session or office hour, or it could come during my office hour. This could be part of your group discussion. So you could, for instance, tomorrow at 1 p.m. office hour, you can show as a group, and then we can brainstorm all these. You can discuss that so that you think of those ideas. Again, it's very hard to, you are learning, so it's very hard to come up with many ideas. That's why it's important for you to just meet with a student, TAs, and as well as me. um, Again, that's why it's very small credit, 5%, and you'll get mostly just by meeting us and just by discussing. So the real things start coming up here now. By week 4 or 5 we'll start writing. Okay. So that's where things get more, because you become more familiar with the topics. All right, so the key point, just um, meet TA um, or instructor um, during office hour or discussion session. Okay, or discussion session. That's Friday. I think his discussion session is 8 to 9:50. I don't know exactly what's the office hour, but you can check. My office hour is 1 to 2 p.m. on Wednesday. Okay. So you can join as a group. Again, all the group member doesn't have to be, as long as you have that coordinations. You can record during that meeting so that you can also share with your group and go over through that. Again, the scope of the projects is very much anything you can do really. So it's not, will not decide it. But if you are thinking of making it web publications, then we'll help you very early what kind of project you should choose, because we have idea about what is publishable, what is not. So that's why we will be more involved in actually selecting the topic for you if it is going for publications. As far I know that the one group that initiated initially, they already are full. Doesn't mean that if you have interest, it doesn't mean that you cannot do it now. Just let me know, send me an email, because it's still early phase. You are discussing different project. So by second week, we can form another group. But we just need a minimum few people to create that um, topic. Again, the reason for class projects is it will give you real world experience of developing a project, writing a proposal for agency. So you learn how to work as a team, because you know that alone you have different style, different people have different style. You got to work with them together to complete your task. This is some good experience. And most importantly, you learn how to write science, technical writing skill. And also you learn how to present well. So these are things you learn if you took class CE159 64 last quarter. But if you're not, this is something you learn again. Um, This is also you'll learn about a conceptual design of a real world project. So you have either a site, real site, and the material or all information about site, and you'll conceptually you'll design where the green infrastructure should be, what kind of green infrastructure it should be, and what should be the design specific. So you'll learn at least some specific aspect of it, but will not actually go on and do anything at the site. But if you don't have a site, there are other things you will learn. But ultimately, you learn the decision making process, how you change certain things here and there. So, as I said, these projects could be anything. It could be green infrastructure specific. For instance, you can decide one type of green infrastructures and do a lot of literature survey about it. For instance, you can choose wetland or bioretention system or retention pond and think of one specific issues related to that. Or it could be site specific. For instance, you could say that I'm going to turn into entire UCLA, modify the UCLA impervious surface into green infrastructure so that it has more infiltrations. Or you can choose one location which has lots of impervious surface. You can go to Google Map and look for a commercial public site. You can decide how you can design that area, redesign that area. Or it could be contaminant specific. For instance, some locations you have, let's say, Bayona Creek or LA River. It has a lot of pollutants, and you know that what pollutants are consumed there and what's the source. Then you can decide how you can minimize that pollutions. So that's the specific related to pollutants. For instance, nutrients, pathogens, metals. These are the very common pollutants you'll see in stormwater. Another is very problem or solution specific. You know, if you know exactly there is a problem somewhere in the world, in mostly in US, and you know this stormwater is the reason behind the problem, then you can try to solve that problem designing a project. So as you see, this could be any proposal, any specific things you can do. This is something created by students, so you can use GroupMe for to find a group if you have not joined any group. I don't know how it works, but I understand that some students know. So I don't think it should be harder. So do it if you have not found any. But if not, send me email. That way I know at least where to put. At least I got two emails, so I'm going to put them in some group, unless they have found any. So that's all for the announcement stuffs. Any questions related to projects? Otherwise, anything else? Okay, so um, again, you can write questions on chat window, so we can discuss that later. This is the learning objective of today's class. You learn about different types of green infrastructures, specific how they look, what's the purpose behind it, what's the overall design, just the overview so that you know at least enough to decide for your project. You'll also learn the components of green infrastructures because every green infrastructure is designed certain way. It has very specific design specifications or component that's designed to serve certain purpose. You learn that. And what they do, for instance, there are components like plants. So do you have plants or not? So they have what kind of soil, what kind of filter media, how much spacing you should have between the space, between the locations, how much grading means how much slope it should have, and all those things you'll learn at least the concept behind it. Then you'll also learn the scope of the project you already learned. Um, Most importantly, at the end, you will learn how to use mass balance equation to learn how much water you are going to receive at locations, because you are going to treat stormwater. If you don't receive stormwater, you can't treat. So you have to calculate how much stormwater you will receive at that site when you design system. You might also calculate how much pollutant you will remove it. So by reactions, simple reactions process. So these are again mass balance concept. Mass balance means things are not destroyed. This is or whatever the mass coming in, you have to account for certain way. Either we'll get to that. But point is, these are all discussed. At least mass balance is extensively covered in CEE159, at least in two classes or one or two classes. I gave you link in the last class. You should see those, and that way you will be able to. If you don't have that class background, you will be able to catch up. The first thing is BMP. So this BMP green infrastructure, these are very much similar. BMP is used for many things. It's not necessarily stormwater. So BMP means best management practice. Okay, so there is best management practice how to prevent COVID, right? So there's BMP is for many things. It doesn't have to be just stormwater. But in stormwater areas, a lot of people use BMP, green infrastructure, interchangeably. So, just so that BMP is everything. Okay, within BMP. So let's say BMP means anything. It doesn't have to be green infrastructure. It could be something like don't build something in that area. So it's the best management practice. You're not building anything. So green infrastructure would be something in between of that. So a small set of the entire BMP is green infrastructures. All right. So this is something again we taught many classes. I just want to show that what I miss is the having the ability for with you to walk around in the campus and show you exactly where different green infrastructures are on the campus. So for instance, here, if you see, this is in 2019, a group of students. And then you see, where we are standing is right near Bolter Hall, where Civil Engineering Department is. And you can also think um, the place where they're standing is a green roof. So that's a uh, sorry, I don't know why this clothes. There is a message coming somewhere. I don't know how to mute it. Okay, anyway, hope that person doesn't respond. All right, sorry about that. So you see that we are standing on a green roof. So green roof is it has a lot of functions. Um, then we can use it for cooling the entire. Um, uh, I'm sorry. Let me tell this person not to text me. There are everywhere there are texts coming, even though my phone is off. It's a computer. All right. So um, then we can show you some other locations. As you see, we are standing here. I'm standing in the middle of the this science courtyard, right in front of the Bolter Hall. You can see this is entire impervious surface. So you might wonder every time there is a rainfall, what happens to those runoff or the stormwater. So it is specific design where this is going. You can see this is one of the infrastructures. This is basically bioswell, means all the stormwater get in here. It slow down the stormwater, allow sometimes to um, go through the process. Some of them can infiltrate into ground. Some of them could just slow down the velocity. Um, this is again on the green roof. UCLA is a beautiful campus, and there are a lot of places you can see green infrastructures. It's unfortunate that we have to do online right now. Right, so there are other things you can see that's not part of UCLA, but when you see them. It's rain garden, rainwater harvesting tank over there, and then you can see that there are other like planter box, permeable payments. Again, you should go to this website so that you can see all them. And one of the question in the homework was what's the objective of green infrastructures? There are multiple benefits. Just want to emphasize that it reduces runoff by infiltrating more water. Because it has more infiltrations, it increase the groundwater recharge. Because it has also less runoff, it decrease erosion. Because if you have more runoff, more velocity, that increase erosions, and that means it has a lot of negative impacts in the downstream environment. And it can also harvest stormwater or rainwater mostly, using those um, device like rainwater harvesting tank over there. And then also it has multiple ecological benefit. Not just it looks green space, but it also helps birds and other types of microorganism or biota to survive. So those are part of ecosystem that's slowly being extinguished, not extinguished. Their their diversity is decreasing in urban areas, and by putting those green infrastructure, we are helping that communities. So there are many types of BMP. I'll go through by function so that you know how to use it, when to use it. So there are green infrastructure which are designed as a pre-treatment. They are not necessarily designed to treat the entire stormwater, at least to remove some of the large particulates from the stormwater. Because if you have lots of particulates, they carry these pollutants and they will also deposit into the system and they will contaminate or clog the system very quickly. So these are the three different types you might see. One of the things is very common is the screen. Every time you drive or walk on a sidewalk, you might see that on the roadside there are places where all the stormwater will get in or runoff will get inside the drainage. Before that drainage, you will see the screen. The reason for the screen is to prevent the leaves to fall into it, so that you can it doesn't clog. And these are pretty big screens, so that's kind of pre-treatments. And then you have also a buffer strip, which is more natural. You can see that this is buffer strip. Okay, this is screen over here, and this is we call buffer strip. The reason is you see these natural plants, they can create as a screen. So when the stormwater goes through that, it will slow down the flow rate and it will block any kind of leaves. So everything will deposit it there. It can remove some pollutants as opposed to the other screen. And then you have a settling pond or settling tank. Let's say tank. Um, if you see how that works, your stormwater comes in here. Because particulates are heavier, this will fall into this hole, right? And then as it fill, only when it fill to the up to here, they can remove the stormwater will go through the system. So it will capture at least the first dirtiest stormwater, which has a lot of particles. So as it build up all these particulates, you can dig them out, and that way you can remove them. So these are a very typical pre-treatment strategy for first flush. First flush, which means that now when it rains, the very first amount of runoff you get. And then there is a sedimentation BMP where the main idea is to settle all the particulates. Here, mostly the big particulates, leaves will be removed. Very fine particulates you will not be able to remove here because they stay suspended. So for suspended particles, it takes a little longer time. So that means you need more time. For that to happen, you need a larger system like a detention or retention pond. Um, so there is a difference on if you see that detention retention, it just sounds so similar. Do you know the difference? Which one is retention, which one detention? For instance, here, which one? What's the difference between one of them is detention, one of the retention? It's hard to know, but let's guess. Which one is retention? Any guess? Let me make a poll. Um, um, you know what? This question over here. I'm just going to put the same question. The question on the um, just show whether it's a left picture or right picture. So between these two, so this is left, this is right. So tell me which one is retention pond. I mean, make a guess. Really you can't see that from the picture, but then I'll ask you what's the difference that we'll remember for all the time. But if you want to remember, think of in a wrong way to say is if you in high school. I don't know about you. I have many times detained in school. So think of that. What does detention mean in high school? Do they hold you for all the time? Like keep you all the time, or they will? So it's about time, how long you'll stay in the school. Detention. versus retention. All right, so we have a in the poll and the share results. Exactly 50% says something, so we don't have a really consensus shares, which is correct because we don't really have to know how to um, how to oh my god, this is people have to text me right now. Sorry, I just have to tell this person. I don't know how to turn it off. I have to. Anybody knows how to do this one? Because all the computer, everything now calls and stops. Okay, so I'll tell you what's the difference. Okay, so the detention, as you see in the high school time or any places, detention mean to temporarily hold something. Uh, um, so that means it's going to be detention means temporary. Retention means more like a formality, or it's a real pond that keep the water for a long time. So here you see over here the water is moving. Yeah, this is just my mean to slow it down. It's really not a pond that means for keeping water for a long time. So that's why it is detention pond. Okay, and this is retention pond. But obviously we don't know what's the outlet, so that's hard to know. But just by look of it, it seems like there's a lot of water that will stay for a long time. So that's why it's retention pond. But a lot of people use interchangeably. And then you have wetland. Okay, wetland is very different. It's basically what it sounds like. It's a land which is wet. It's a large area. Water moves very slowly, very shallow. It may have plants, it may not have plants. It can be redesigned. So we'll learn all that. But this is just one type of wetland. There are many different types of wetland. There is a question from William. Do you ever have to consider how this sedimentation BMP would breed mosquitoes or other disease-carrying bugs in a particular climate? Yes. So, in fact, the one of the critiques of any green infrastructure is mosquito. If the any system which retain water for a long time, mosquito will breed there. So that's why many kind of BMPs, the requirement is 48 hours. That means within 48 hours, all the water that's there, infiltration based systems, has to infiltrate. You cannot have ponding for longer. But detention pond is otherwise because it is designed to hold for longer. But any other system, you don't do that. And here, particularly in detention pond, mosquito is not a big problem because it's exposed to sunlight. Sunlight will kill any kind of larva. But it's places where it's a swampy area. That's where you have issues like wetland. But again, it has its own ecosystem. You're not expected to have wetland right in the middle of the house or the middle of the communities. So it has its own ecosystem to have that balance. But mosquito is a big part. So you got to design such a way that it will not have ponding for more than 48 hours.
Professor?
Yeah.
So sedimentation BMPs, they only remove large particulates and not suspended
Uh,
particulate?
it's based on Stokes law, so we can calculate that if you know the size of the
Okay.
flow, which you'll learn. I mean, you already learned in CEE159, but you'll relearn again here. But yes, you're right. So if it is less than, let's say, 5 micron, 2 microns, or 5 micron around that, it will not be removed unless it stays for a long time. So by rule of thumb, anything about less than 2 micron, which is clay particles, will not be removed. Anything sealed or bigger than that, sand size will be removed. All right, so there is another type of BMPs, which is capture and use. Capture means capture the stormwater and then you somehow harvest it for using for certain purpose. So here you can see that there are many plant. What they do is here they takes the building water. If you have gray water from building where you wash hand, those water instead of sending them back to wastewater treatment plant, they put it inside here. That way they don't have to irrigate this land. And so what it does, it'll reduce the cost of irrigations because you are reusing the water, And then as in percolate through the system, it also it filter the pollutants, which are not a lot. So then they can put that water in underground cistern or capture device, and then they can reuse it by filtering them using UV infections. Because only thing you care about is the pathogens. There are not much chemical there to begin with, so you don't have to worry about that. So they filter it, all particulates, and store them, and then they use UV disinfections to remove any pathogens, and then they reuse it. It's pretty clear. So it's a circular process here. So capture and use BMP, the function is to capture stormwater and use it. Okay, as it says, these are the functions. Okay, so it filter, then store disinfections, reuse, then you divert again. Okay, so that way you reduce your water bills, and also you have these nice places. Obviously, it's not all water is recovered, but at least they're being reused. Um, there are other capture and use device where you don't have any treatments, which is called underground cistern, which is basically big pipes that you store water underneath. You just dump all the pipe. So these are usually designed below a parking lot or below a soccer field or any kind of big field. So these are many examples. If you go to Santa Monica Pier, this is a big area which was designed like this, and many other places has been already in place like this. So that this the only functions for this one is high volume storage. High volume storage. So these are pretty expensive to build because it has a large footprint. And so that means now you can only build this kind of stuffs where you have lots of space as well as you expect to receive a lot of stormwater. If you don't receive a lot of stormwater, you are developing these infrastructures that are not enough water to compensate for the cost. So these are things you have to think of. And these are pretty effective for dry area because you receive a lot of rainfall very quickly and then you store them. Then you can use for a long time. Then this is by far the most common as well as more effective is filtration based BMP. Filtration means like what it sounds like. You have some filter layer like you see, mostly it's a soil, sand, mix of sand and something else. It could be some soil, it could be compost or mulch, it could be wood chips, it could be gravel. So the fact that it's passed through certain system, it removes some particulates. So there are a lot of other, these are a lot of things that classify as filtration BMP. Then there are infiltration BMP. The difference between filtration and infiltration is whether it is going to a storm drainage or it is going to groundwater. Infiltration means it's just percolate through soil and get into groundwater. And there could be also a combination of both. So next time when you hear infiltration, it means it's going to ground. Filtration means it's going through a filter layer and then it is going to a storage somewhere else. Um, again, this just to example, this is given. Water infiltrate into ground after treatments. Filtration means if diverted to a pipe. Again, this could be combination of both. For instance, here you see this picture. Um, Obviously, this is this one will be both infiltration and filtrations because the pipes are perforated here, all the collection pipes, so that could also um, drain some of the water. And you get some high amount of flow. When there is high amount flow, you get in the here, but rest of them also infiltrate into ground. So it's a combination of both. So we'll not get to detailed design about it, but just know that you have a source of where water is coming in, then you have some kind of filter media. There are mulch, amended soil, gravel, why there are different locations, why gravel is at the bottom, all those things you'll learn later. Just know that these are the functions. And these are just different design. And as usual, if I ask a question on quiz between bioinfiltrations and biofiltrations, which one will have higher groundwater recharge? Obviously, infiltration is groundwater recharge. Filtration is not, unless you have, there is some hole in the pipes. So usually infiltration helps groundwater recharge. Filtration, you just store somewhere else and reuse it or discharge it to surface water. So that's the key difference. And then you might see this one very common is a vegetated swell or filter strip. The one I show you is basically you have a swell means if you have a shallow area, or not shallow area, but it's a depressed area, little not too big a hole, so that stormwater get into that area and slowly move through that. So that's the vegetated swells, and the vegetation layer on the bank or the side, they filter large particles, large sediments. Okay, and then stormwater move here, not down but side. It's basically a channel, natural channel. Filter strip, on other hand, is basically it's coming from a surface like a high elevated surface to low elevated surface. It has to pass through a planted layer so that it can remove everything. All right. So any questions? So now you learn most of the different types of BMPs or green infrastructures. Now we'll get to the different function of it. But any questions?
Professor.
Yeah.
So the infiltration removes the runoff from surface water.
Uh-huh.
So would it be retention or detention?
I think it's a good point. It depends where it is removed, how long it's stored. But as I said, it's very interchangeably people use. The only
Mhm.
place it matter is a pond. Every other places things don't stay longer. As I said, by default you have to have maximum 48 hours ponding time for mosquito control. So when you have you cannot store water more than 48 hours. That means on the surface, it's already by default it's detention, right? Uh,
I see.
So that's why the only place I would say retention is the pond, okay, where you keep the water long. Or if you think of cistern, underground cistern like this one, it's a retention because you hold them for a long time for use. It's just how you say it. It's really not a big deal if you say a different way. But you should know the reason behind it.
Okay, thank you.
Mhm.
For the water that ends up percolating through permeable asphalt, for example, does it sometimes pick up more pollutants as it starts filtering through something like that type of concrete? Or does it end up treating itself over time?
So it's a good point. So a lot of times filter are not necessarily clean. They have also pollutants. So asphalt, um, it depends, what pollutants there. Most asphalt doesn't have it. What they release is silica, which is not a pollutant, like sand. Sometimes if it is cementous, they increase the pH. So pH, it increases also temperature because they are hot, warm. But it's as per releasing pollutant heavy metals, they are not as much as what is already in the stormwater. And most of the time, the permeable pavements or those kind of things are designed to remove particulates. They are not designed to remove dissolved pollutants. So you're really not thinking of those. And they move so fast through that system that it doesn't have enough time to leach stop. Um, but you learn all the details once we get to the individual type design, because we are just, I'm giving you overview here, not going details. All right, so let's think of the components of BMP or the why different designs are necessary. So on the left side, I wrote different functions that green infrastructures are designed to do. And then the design component will think of what's the design component that will help achieve that functions. Let's start with the first one, reduce impervious surface. So what are the things you need to do if you have to reduce impervious surface? The very first design component is remove it. like remove it and replace with a bare soil with a planted area. So this is basically planted area. If you just take the cement out and just put a grass, that's already a BMP, okay, because it doesn't really block all the runoff. So it's a design component is all about infiltrations. It is allowed to, it's designed to increase infiltrations. All right, decrease erosion. How do you decrease erosions? Erosion is related to, if you think of how erosion occurs because you have water moving very high velocity. Water moving slowly does erode, but it's not that much. So the energy of water is important. So how do you slow down the energy of water? Any suggestion or any? I mean, these are all very logical process. So I mean, it's nice to make these kind of wild guesses. So think of how you.
Maybe like a bioswale.
Yeah, exactly. So this is another thing. Every retention pond by default slow down the flow rate, or every green infrastructure, because the fact that it has this roughness, because you are removing this impervious surface, by default the energy is now slowed down because you have more resistance. So anywhere you can, so this means velocity decrease. The only way you can do it if you increase the resistance. And how do you do increase resistance? If you have more plant or holes, think of any kind of maybe rocks, put some rocks on the way so that it just slow down, or any kind of system. So every green infrastructure is designed to slow down velocity. Okay. And also volume of water. If you have more infiltration, by default it has less volume. That means already less velocity. Increase retention or detention. So what's the function? If you want to retain more water, what you should do? Any guess? Let's say if I say that no, you want to hold more beer, and you want to go to a bar and you want to get as much beer possible in one time. What do you do?
Can you increase the porosity?
Exactly. So you basically get a bigger container, right? So the bigger space. So if it is filtration media, you porosity, um, you can increase the porosity. If it is not porosity, just basically you can increase the depth. If it's retention pond, you just increase the size, right? So size, increase. Size means either area or depth or all that. Increase infiltrations. How do you increase infiltrations? Anything that you guys learn in CEE159, or just think of if I pour water, infiltration means how quickly it percolates through soil. So if you go to beach and you pour Coca-Cola or just water on a beach sand, it will disappear very quickly, right? But if you do the same thing on a parking lot, it doesn't disappear. If you do the same thing on, let's say, on your garden, it takes some times. So what's the difference between those three? What do you call that?
It's the permeability or like the hydraulic conductivity. So
Exactly.
you'd want to look for a type of medium.
Exactly. So you do change the permeability. Okay. And so permeability, hydraulic conductivity, that's based on Darcy's law. Again, that's in CEE159, but we'll cover that again. So it's not, you'll see them again and again here. So if you don't take that class, not like you'll not understand it. It just you'll use the same concept for these specific applications. And how to increase permeability is basically also related to porosity to some extent, not completely true. Basically have less frictions. Yeah, more pore space, it will increase infiltrations. A lot of times, something unique is plant. If you have more plant, they also increase infiltration. The idea here is that plants have roots, and those roots will go through soil. They'll create those channels because root will die, and so that will create that permeable, that space, pore space. Because root will not survive for a long time. Many grass, they will die, they will decompose, they will need roots. That's how they makes the soil breathable, and that's how also increase the microbial diversity. So having more plants also helps in permeability. Remove pollutants. So how do we design systems something that can remove pollutants? So it depends on what pollutants. Let's say sediments, you already learned. You don't have to filter it somewhere other, or sedimentations. So I'll write here sedimentation. So that's if that's particulate, okay, or filtration. If it is, let's say, big plants or leaves and all that, you can filter out by just putting a strain or plant. What about dissolved pollutants? What's the way to remove dissolved pollutants? Any suggestions?
Maybe some like chemical reagents.
Yeah, so it could be, dissolved pollutant can be removed many different ways. One is the chemical reactions, reagent you can add. What other? Think of, I give you a dye. Dye means the color, and you want to remove color from your water. What do? Let's say you have dye on your floor, okay? You somebody spill it. What you do if you have to remove that? Obviously, reagent chemical is one thing, but what's the basic thing you do?
Put water.
Yes, and you take imagine if somebody spilled just on your dress. What's the instant reaction? What do you look for?
Bleach?
Oh, you not put bleach on your surface because you'll destroy the. Think of, I spill something, a food here while eating. I do it a lot of times.
You just like wipe it or like
Yes,
rinse it
you
with
wipe
water?
it with something, right? What is that?
Some kind of cloth. or-
Absorb it.
Yeah,
Like-
cloth or paper towel, right? So what paper towel? Why paper towel remove the things easily? Why not anything else? Why not I just take this one and do it? Doesn't do anything, right? So what's the reason behind it? What's speciality about that paper towel? I'm looking for a word. Okay, so
It's absorbent?
yeah, basically it absorbs, right? So absorption is the ability of pollutants to move from one location or liquid medium to stick to something else, right? So that sticking or absorption is what is needed. And so Ambrose says that chemical reaction is reagent is expensive. Imagine if you have tons of rainfall. Imagine the management aspect of it. Somebody is looking for rainwater and then they will add the reagent immediately because it doesn't. So most of the time it's the absorption or the sticking of pollutants or something is effective. So you add that adsorbent or something that scrub the pollutant away from water. So that's we call absorption or adsorption. It depends on, let's call it sorption. We'll learn about that. Sorption or sticking. And the way it does it, you add a filtration media. So you add compost, mulch, biochar, activated carbon, all those things that you add that has high capacity to absorb pollutants. So this is another design component. So as you see, this is all it takes for designing BMP. This is the whole aspect of how you design. There are not many difference. So what we are going to do from now on is going to look for each of these processes and we'll use equations to describe that process so that you can solve it or quantify the removal of pollutants. Now that you know all these process, I'll show you how it is done in this different type of example. For instance, here, this is a bioinfiltration system because it filters into ground. It's called bioinfiltration because it has plant, it has microorganisms that degrade it. Okay, so stormwater comes in here. Imagine stormwater is coming very fast. What will happen? if I'm just pouring in a really high flow rate, what will see over here? What do you see? What might happen here? If the velocity is very high.
Would you see lots of erosion?
Yeah, so it's basically you'll see all these soils will be eroded away, and these plants might be also uprooted, right? So there'll be no function here. So that's why anytime you see this kind of design, they don't really put directly water there. They have to slow down the water before it enters here. And the way to slow down is they put basically rock, okay, big rock before it. And basically they make a hole and fill with rock so that water will come through that and fall into it. And this big rock so that it just slow down the water. So when water comes here, it passes through it or it slow down the water, velocity will slow down, it will get in here. So it kind of pretreatment. So you can see that in real world. We'll show you when we see the example, but this is just a schematic to show. The idea here is to prevent erosion and remove debris. This is just one way. Another way, this could be just a big hole. So what happens is, as I said, stormwater get in here, it fills the systems, then all the particulates are removed, and then it goes into here. Okay, but this cannot slow down the velocity once it's full, because once it's full, things will move on top of it. This is more of a sediment trap. But rocks are real velocity or the breaker, velocity breaker. And then you have plants. Plant itself has ability to prevent erosion because the root systems are bind the soil. So if you have lots of plant, it kind of make them stable. Plant also, they remove pollutants. So learn that how it is removing pollutant. So plants are integral part of many design because it does help increase removal of nutrients. So they need nutrients to grow. They remove heavy metals by absorption on their on the root. Some of the pollutants can be uptake by plant. Plant also help creating microorganisms which can degrade pollutants. So they have their own functions. The another thing is retention pond. So what's the reason for retention pond? This is our ponding area. So it says, it already tell you what's the reason behind it. The idea for it is that if you have more volume of stormwater capture, you treat more water. So you want to have that depression, the hole little bit larger, not too large that people will fall into it and they will hurt themselves. But the idea for that one is capture. You capture more stormwater so that it can be percolated into ground. So it increases the treatment volume. And another thing is you learn from CEE159 or other, if you have higher volume, it increases the head. That means the pressure of water below the inside the pore is much higher because if you have larger volume of water. So that means if you there is the infiltration will be much higher. It's the same thing as think of if you have a coffee or some kind of tank where you collect water or you drinks, collect drinks. And so when you open at the bottom valve, things come out very fast when you have higher volume of water. So that's the exact same thing. So if you have more water ponding, it increases infiltrations. That means it will increase the groundwater recharge. So if you want to increase the recharge function, you should be able to have some kind of ponding. It also removes sediments because it has the filtration ability by having that plants. Then the final component is the filter media. This is the main function of this system is because it removes pollutant, dissolve pollutant, which is otherwise not possible to remove. And most of the time, they are designed to remove pollutants. So the filter media could be mixed up sand. The reason we put sand is because you want the water to move fast enough so that you can capture more and more water. So main component is sand so that it increases infiltration. What sand does is increase infiltrations. But sand itself doesn't have much capacity to remove. So it's usually mixed with some other amendments like mulch or compost activated carbon or biochar, zeolite. There are many adsorbents. Think of any kind of natural materials that you can add. So these will adsorb pollutants. And they also provide nutrients for the plants above so that the plants can help grow. So they have other functions as well. The last one, as you see over here, this is the storage layer. The function of storage layer, it can capture enough water so that it can be used later. Because the filtration layer usually is not high porosity. Because if you have very high porosity, things will move so quickly that it will not remove pollutants. Whereas in a transitional layer or storage layer, you want the porosity to be high so that you can store more water. And in this particular case, storage layer, you see the raise outlet. The reason they raise the outlet is because they want to keep it saturated. If you raise the outlet, that means you can store water up to here, okay, before it discharges outside. That means increase infiltrations. Again, anything you can do to create the head will increase infiltrations. And also, if you submerge it, it does have lots of microorganisms which become, when some area it is completely submerged for a long time, you start feeling there is a stinking. So if you keep something for a long time in underwater, it stink. That's exactly what will happen here. The reason it stink is because it become anaerobic, because more oxygen are gone. And once it become anaerobic, it can remove nitrate. So that's why we'll learn about that. So just know that if you have submerged layer, it helps in denitrifications because it creates these anaerobic zones. The last one is drainage layer. The whole ability is to allow water to move as quickly as possible and reuse. So mostly people use here gravel. Okay. So that's all in terms of the design. So these are the learning assessment questions you should know. So what we should again think of this for your homeworks or projects. So these are things will help you. So now we'll take a break for 10 minutes. When we come back from 10 minutes, I'll just briefly describe what is mass balance. But I want to tell you that everything on this slide is already pre-recorded. Okay, so that means you can go back either these links to watch them on CEE159, but these are not the same as in these slides. But here, any question that you see over here, if I already pre-recorded before, these are uploaded. So what we'll do here is that we'll just go through very quickly and then we'll solve some problem as a group. So I want you guys to break into multiple group, and if you want to leave, it's fine because it's already recorded. You can watch later, but we'll solve some of the questions as a group and we'll discuss that. So we'll meet at 5:15 and then we'll learn some concept very quickly, 5-10 minutes, then we'll solve some example problem as a group. So I'll meet you, let's have a 10-minute break.
Professor Mahanti?
Yeah.
Oh, I just wanted to confirm. So basically all the 10 slides that we went through just now, they're all talking about different components within the same bioinfiltrate system,
Yes.
right? Okay.
Yes. Because this is the most common one, so that's why I use this one as an example. Because you can remove some components, still it will work. Just you know what you're removing. Okay, so I'll stop recording. Right, so before the break, we learned about different design aspect of green infrastructure, just an overview. Now we start going to use concept of mass balance to solve how much stormwater you have in a system, how much you receive at a system, how much pollutants you can remove from a system based on the design. So again, this is very similar and the same thing as you learn in CEE159. The only difference is you are just applying for stormwater. So I suggest that again, you should go back and read those. If you don't, if you have not taken this class, watch those videos. Those links are given on the slides. But I'm just going to go through the things very quickly. So these are the slides given already. So just check that on. This is CEE159. But everything that is from this now on 35 to onward is already part of a recording that I already uploaded it. The reason is I know that these are examples, so you just repetition from CEE159. So it was pre-recorded, so you can just watch them later. But I just going to explain very quickly what is mass balance concept so that we can solve at least one example here in the class. Then we can break out room if you want to stick around to solve more problems. But those are already solved again. So let's see what is the conservation of mass means. It means that if you receive, there are two types of mass we are looking for here. Mass is mass of pollutants and mass of water. So these are the things coming into the system. Okay. So either of them is conserved. Okay. What that means is everything that's coming in has to be what's leaving the system plus what is being reacted or stored in the system. So that's why mass balance is all about what's everything, where everything goes. So let's say this is green infrastructures, okay, the system, or we can call it a system. Stormwater usually coming in. Okay, so let's say this is stormwater coming in. Then you have some kind of treatments or storage. Then you have also leaving the system. Okay, outflow. So usually you know if it is pollutants, you know the concentrations because you don't really know the mass. You don't know how much is being added. You just can take a little bit, grab samples, and you know the concentration of pollutants. So you can call this is C in. And then you have also known the flow rate, how much amount of water. This is basically a water flow. Okay, so this is water. This is pollutants. And some of them might be stored. Let's say this is the volume. Okay. So you know the volume so that you know how much is being stored. Then you also know what's the flow rate out. So Q in, this is Q out. And you might also know what is C out. Usually you are asked to solve for C out because that's one thing that you are going to, your TMDL or total maximum daily load depends on that C out and Q out. So you don't want to add too much pollutant discharge into system. So that's why you are controlling C out using green infrastructures. In fact, sometimes you are controlling Q out. You don't want to have a runoff, very high runoff, so that no flooding occurs. So basically these two are your output or those things you are solving for. Okay, using mass balance. So the mass balance concept is very simple. As I said, it means any times change in total mass in the system is equal to any times the mass coming into the system minus total mass coming out of the systems plus or minus any mass reacted. This is reaction, storage, all that. M is mass. Okay, the mass mass of the pollutant. Mass is conserved, not the concentrations. So now, as you know, this is the mass balance equation, but as you say on the upper pictures, I didn't show anything related to mass. I just give you concentration and flow rate. How do you change mass into concentration and flow rate? So that's all things we need to learn. Concentration, so if you know the pollutants, concentration is mass per volume, mass of pollutants. So concentration of pollutant means mass of pollutants divided by volume of water, right? So that means if you want to change, if you are doing pollutants, you just simply have to concentration time volume. Okay, so this is volume of water. And if you want to do the mass of water, which is basically mass of water, how do you change to flow rate? So, well, you know that mass over volume is density of water, which is kind of constant, right? So unless temperature change, density doesn't change. So mass of water is mass divided volume is density. That means density times volume is mass. So this is density. Okay. So this is mass of water. If you take the derivative of this one, so d mass of water divided by t, it will be density times velocity. Okay. And you know that density of water doesn't change much. It's changed with temperature, but temperature doesn't vary so much. So that means the density is a constant. It comes out of the derivative. So it will be dV by dt. So that means it becomes volume of rate of volume changes over time is basically flow rate. So density times Q. So if you want to use these equations, and this equation, the above equation can be simplified. Again, check the video. I don't want to go describe. Basically, this will become mass equal to, if you do for concentration, it will be concentration times volume. So concentration, if it is constant, this will volume is constant in a system, because any system, if you're a pond or something, the volume is constant. So the volume will go outside here. This will be dc by dt. So that means anytime you can predict the change in concentration in the system if you know the volume of the system, okay, which is normally given because you design it. And then here, how much mass of pollutant coming in, the way mass of pollutant coming in is by flow rate. So usually this will be dm by dt is basically concentration time volume by dt, right? And here, when it's coming in, obviously I'm going to write it here, okay, that way nobody is going to be confused. This will be volume time concentrations coming in minus d by dt volume time concentrations. This is out, plus minus d by dt volume time concentration reactions. Okay. So now I'm going to write in a different color so that you know what that means, the final equations. So the concentration in what's coming in, usually you can assume this is constant because coming from a source. So if you assume concentration is constant, this will be C times dV by dt. dV by dt is Q. So C in, Q in. Because dV by dt is Q. Okay, that's what is here. dV by dt equal to Q. Same thing here. This will be C out, Q out, plus minus. Again, volume of volume of the system is constant, so this will come out. This is not the same volume. This volume is the amount of flow coming in. It's not the system of volume. So volume of a system be dc by dt. dc by dt. This is reactions. So that's be dc by dt of a system. So this is your mass balance equation. Basically, you take this equation and solve any problems that you have in the example. So I'll go through that, all of them. And again, just to show that the system could mean detention pond or lake. So you have a boundary, things are coming in here or here, that's how you can count. For instance, here, you can make the system boundary like this. Okay, so things are coming in, things are going out, and that way you can calculate that. Over here, this is a bioretention system. You can say that if the boundary is this system boundary, things are coming in here, then things are going out here. Okay, so you just have to identify what is in, what is out. Again, check CEE159 so that you know these details. I already solved this one. I just I wrote the entire equation here. What is that mass balance equation means? A lot of times you can break it down to different system. So number one is steady state. Steady state means the system concentration doesn't change with time. What that happens is that whatever coming in is also reacted, so there is always equilibrium. So it's so that means that the change in concentration because of reaction is same thing as what is being delivered. So net change is always zero. So steady state means again change in concentration of the system equal to zero. That means concentration in the system is constant. Okay. So this is just a steady state for concentration pollutant. But if you say steady state for water, that means this will be Q in minus Q out, Q in equal to Q out. Okay, so that means there is no change in volume of the system because volume is the mass of a substance. So this is for sum of all flow rate is sum of all flow out is the steady state equation for water, and for contaminant this is for contaminant. Okay. Again, check this is again repeat of what you know already 153. So I just giving you overview so that we can solve it. So these are examples. This is how we can solve it. For instance, here two river meeting. So if Q in coming in, this is Q west, this is Q river upstream. So if I ask you what is the downstream flow rate, then you know that if this is the system, whatever coming in has to be same as what is going out. So that means at steady state, there is no change in volume. So that will be some Q in plus Q river up has to be Q river down. So this is all in, this is all out. Okay. So these are different examples, so we'll solve it, but I just want to make sure that we'll solve one question, but everything is already pre-recorded. So any question until now? We'll randomly solve one question, okay? So let's see. Again, these are all solved in the recording, so I don't want to redo it here. Let's solve one of these, what looks like a difficult questions, or at least, one of them. I don't know, I just pick one of these reactions. One with a reaction, one without reactions. So let's see, there is no reaction one. This has a reaction. This doesn't have a reaction. So let's use this one. Okay. Okay, so it says that a storm swell is carrying snow melt containing 1.2 gram per liter per sodium chloride into a small stream. So there's a swell coming in here and mixing with a stream. And the concentrations are basically given. So the concentration that coming in is 1.2 gram. The flow rate of this is a 2,000 liter per minute. The stream flow rate and concentration is also given. And I ask what it says that because there is no, it's a steady state, there is no change in volume, we can always assume that sum of flow rate coming in has to be out. So that's why the flow rate should be the what is coming in. So that would be, if you add them together, that will be 2000 liter per minute plus this is 2 meter cube per second. How do you add two different units? You can't unless you convert one to another. So that's why we have to change it. So 1 meter cube is 1000 liter. Then you also change to minute. You know that 60 seconds is 1 minute. So that means this will be 2000 liter per minute plus, if you multiply that, this will be 6 times 2 is 12. And then you have 3000 and 12,000. Okay. So this is liter per minute. Of course, you could have changed everything to meter cube per second if you want to do it less. So this will be 1 to 2,000 liter per minute. Okay, so you solve for the flow out. Now you have to solve for what is C mix. So again, for mass balance, you can say that if you start with that same equation, it says somewhere it is steady state. Let's look for this one. Somewhere it says steady state. Okay, so steady state, it says that means dC by dt in system equal to 0. So that would be, this is C in, Q in, C out, Q out, plus a reaction term. And it says that it doesn't react. Okay, so that means reaction is 0. So that means all you have to do is everything that's coming in has to be everything that goes out. So this is the reaction, summation. This is everything. That means everything that coming in, not just one. So what is coming in here is CSC time QSC. That's one channel here. This is one. And this is second in, which is a street. CST times QST minus what is leaving the system is this. So that will be Q mix times C mix. So you are solving for C mix. So that means C mix is CSC QSC plus CST QST divided by Q mix. Everything given, the only things that you have to change is to change the unit to same unit for flow rate. Everything else is given in the, no, actually one is gram per liter, another is milligram per liter. So that means you have to change to gram per liter or milligram per liter. For instance, if you change milligram per liter, it will be 1.2 gram per liter and 1 gram is 1000 milligram. So that will be 1 to 1200 milligram per liter. So now every units are same, and then you can use the units accordingly. So you can solve for it. So this is one example. But what if there is a reactions? So if the reactions, just want to, if again, what the reaction means, it means that something is being removed or reacted. So the change in concentration because of reaction depends on reaction rate. If the rate is high, it will decrease very fast. So usually that's the equation for reaction you can describe by simply a rate constant. So this is called a rate constant. And then it's a C to the power something. Okay, so this is a power n. So this is order of reaction. And the concentration of pollutant change with time or decrease with time, then that means as the time progresses, as the time increases, concentration decreases. They are opposite directions. That means you have to put a negative sign here to balance that. So this negative sign means its concentration decrease with time. Okay, if it is created, then it's a positive sign. So for first order reaction, which is most of the cases in any times you think of, very rarely you'll have more than first order reactions. Sometimes you may have zero order, but that's also rare, but we'll tell you. But let's assume that everything is first order reactions. So that means first order reaction means n equal to 1. What it means that change in concentration in a system depends on the species concentrations. If that's the case, you can substitute this value in this reaction term. If you have a reaction term which is here, there is a reaction term here. So basically you could say that this is volume. If it is first order reaction, this will be Kc and negative sign. That's for first order. and then you can solve for C. Okay, so now question is, what is that C means? So one of the assumption is that when there is a reaction, what is being reacted in the system, the resultant reaction concentration is what is coming out of the system. So a lot of times for reaction, you can assume that if you have a system like that, is coming in, C out, it's a volume and it's being reacted, and this is C reaction, inside is C. So because there is no reaction taking place outside the system, so after reaction, whatever the concentration, it remain the same. So a lot of time you can assume that C equal to C out. Okay, because they are, once it leave the system, it doesn't react anymore. So if you put those two assumptions, you can substitute K C out in the equation and solve for C out. So that's what exactly it happens here. So I'm going to solve it. Again, these are all there for the same equation. I don't know whether we need to solve any of them, but let's solve this one. This is similar to what the other question was. So then you can check everything else in the example recorded video. Again, these are all solved before, so you can watch them, but I'm just going to go through it quickly here. A well-mixed wedge lagoon is receiving 430 meter cube per day of untreated sewage. The lagoon has a surface area of 10 hectares and depth of 1 meter. So basically, tell you what's the size. If it says the depth, it's a rectangle, then you know the volume. So the volume of the reactor is given, which is 10 hectare times that's the area times the depth. So this is area 10 hectare and the depth is 1 meter. Again, you have to change everything to meter cube. So look for what is the 10 hectare means per square meter, that you can change it to meter cube. And if you know meter cube, also you can change to liter. Okay, because 1000 liter is 1 meter cube. So basically it giving you the volume of the reactor. A pollutant concentration in the raw sewage discharged into lagoon is 180 milligram per liter. So that's given. Concentration coming in is 1180 milligram per liters. The organic matter in sewage degrades biologically or decay. That means decrease with time. In lagoon, according to the first order kinetics. Again, that means all you are saying is dC by dt is minus kc. This is the first order reactions where the exponent is 1. And the rate constant, the k value, is given here 0.7 per day. Okay, that's the unit of first order reactions, or the rate constant. Because concentration cancel out. If you see in these equations, this is concentration over time, this is concentration. So both side concentration unit cancel out, so it will be 1 over time. Assuming no other waste water loss or gain, that the lagoon is completely mixed, find the steady state concentration of the, so again it says steady state. What that means in that reactions, you can assume that dC by dt in the system equal to 0, the left hand side. That means it's a steady state. Then you have to solve mass balance diagram, then you have to solve it. Okay, so let's solve this one. If you write the equation, mass balance equation again, V dC by dt system, it will be Q in, C in, Q out, C out. I'm just writing that one first, okay? Then V dC by dt, okay? The reaction, dC by dt reactions. So because it's a steady state, this becomes 0. Okay, so this is 0 because it's a steady state. So Q in, C in. So that's basically given to you. Q in is 430. Okay, let's first write everything. Q in, C in. Again, there is no change in volume, that means whatever coming in has to leave the system. So that's why what is going out is the same thing. So you can write this one as a Q as opposed to Q in and out, because they are all same. So Q, then you have C out. Then the reaction is basically first order reaction. So you write K C. Okay, that's the first order reactions. dC by dt is minus Kc. Again, one of the assumption is, as I said, whatever reaction happens at the end of the reaction is what leaving the system. So that means C reacted reaction, or what is after the reaction is same as C out. Okay. So you can, if you write this one, balance it out. So this will be C in, QC in, minus QC, C out equal to C, that's the assumption, minus VKC equal to 0. So that means concentrations, if you 0 QCN, if you Q plus VK. I'm just rearranging because you are solving for what is the concentration. So if you rearrange again, it's QCN divided by Q plus VK. If you divide Q in both sides up and down, so it will be C in 1 plus volume over Q times K. Everything else is given. Concentration in is given, volume is given, flow rate is given, K is given. Just plug the value, make sure the units are cancel out. That way you get the concentration in, what are the unit of concentration C in, it will come out here. So again, as I said, this is something you, if you have not taken mass balance, you just need more time. So you should, the next homework will have a lot of example like that. And I already solved these multiple different types of example and uploaded on the class website. So you should watch them. First try to do one by yourself if you already have some concept of mass balance. If you don't, then watch the CEE159 video and then try to solve this problem. Again, the examples are also same in CEE159 as well as here. So this is all you need to know in terms of equations, how to solve how much pollutants can enter and leave the system. There are some complexities, but we'll go through that whenever there is an example. So again, I didn't write anything because we solved it. It's all recorded. So the last thing is next class, we are going to learn about fundamental processes that remove pollutants. I didn't tell you what kind of reactions. So that's exactly what we are going to explain next class. So that's all for the class today. I'm going to stop sharing. And if you have any questions, we can discuss now.
Professor Mahanti?
Yeah.
I wanted to ask, so for the quiz this week, we'll be tested on lecture 3, but would we be tested on doing like
No
the mass
equation.
problems?
No quantitative problem. It will be only qualitative. Like steady
Okay.
state means concentration doesn't change with time. That's the question.
Okay.
No math. Because you have only 2 minutes to do it. All right, so I'm going to stop recording.